Hi all. A lot of you have been asking repeatedly as to how can you fine-tune your own conversational chatbot utilizing your own conversational dataset. In our earlier videos, we discussed how you can build your own ChatGPT like chatbot utilizing some of the tools such as LangChain. I'll attach the links in the I button above. Now, in this particular video, we are taking a step forward and we shall be fine-tuning DialogGPT medium model to build in order to build our own conversational chatbot utilizing multi-turn dialog dataset. Now, we shall see a step-by-step approach as to how we can go ahead and fine-tune this DialogGPT medium model. For that, we shall first need to install some of the necessary libraries, which include the datasets library. Since we shall be utilizing the CUDA enabled environment for this purpose, so we need to install Torch, Torch Vision, Torch Audio, and the CUDA driver libraries corresponding to the Torch we have. We ran this entire notebook in a Google Colab environment so that all our learners can make quick ready use of this particular notebook and go around and play with it. Okay, so the constraints or the resource utilization for this particular fine tuning has been kept considering the resource constraint available in the Google Colab environment. Okay, so let us run this some of these cells one by one. So we shall install the data sets. We shall install some of the necessary libraries. We shall install Torch and Accelerate for the purpose. Okay. Now once we have installed these libraries, next we shall import the datasets and the auto classes from transformers. The reason we are utilizing transformers auto classes instead of pipeline is because we are trying to fine tune and therefore we require much greater control as to how we load the model and how we utilize the model. I have covered this auto classes and pipelines separately with respect to the transformers library. I'll attach its link in the description as well as in the I link above. You can check after watching this video. Okay, so once we have loaded these libraries, next what we are going to do, we need to load a few more libraries such as the torch library, and you can also import warnings to avoid unnecessary warnings that might arise while computing. We are checking if we have CUDA enabled in our environment. We are doing this by running this particular command, and we see that CUDA is enabled within our environment. Now, the model ID that we are utilizing is Microsoft DialogGPT Media. This model ID comes from the Hugging Face Hub. Okay, you can very well take any other GPT based model which if you want to utilize for your conversational chatbot. Now, the device we specified is CUDA. We are loading the tokenizer using auto tokenizer. We are specifying the padding side as right. Microsoft Dialog GPT was actually trained and requires the padding side to be on the right side. Now, in most of the GPT based models, by default, pad token is missing, and therefore we check if pad token is missing, then we specify the EOS token as the pad token. This is necessary because in fine tuning, we shall be running batches of inputs at the same time. So padding becomes necessary. We load the model using auto model for causal LM. Causal LM because GPT based models are causal models. And in order to fine tune them, we need to utilize the causal learning methodology. Okay, so we load this model and we put it to the device, which is the CUDA device. Let the model be loaded. Meanwhile, if we look at the tokenizer, we see some of the parameters that we specified, such as padding side, truncation side, special tokens. If you look at it, the pad token has been taken as the EOS token. Okay, so this is what we specify. We can check the model device. We see that it is on the CUDA environment. Now, the next step that comes up after loading the model, loading the tokenizer is pre-processing the dataset. The dataset that I have is a multi-turn dialog dataset. This has been curated. I'll share the link to this dataset in the description. You can check it out. Now, if you observe this, right, the context that we have at index 0, then the following response. The response that we have at index 0 comes as context, it comes as the first context, thereby the first response comes as the second context, and so on. This is because we want to maintain the continuity of the conversation, and thereby we have a multi-turn dialog data set here. The input variable or the input feature that we have is just a concatenation of context and response. We shall look at it why we need to concatenate these two and create a separate variable. This is essentially required in the fine tuning process with the trainers module. Okay. We next check the shape of the data that we have. So we have nearly 3700 records and three features. And we also check the memory usage in terms of kilobytes. Okay. Now, what essentially we need to do is, because we are utilizing the trainers module and it works very well with dataset objects. So we are essentially converting our pandas data frame into a dataset object with the help of this dataset dot from pandas, and then we specify the data frame here. Okay. Okay, I did not load this. Let me just run this up. Okay, let me check the path. Okay, so this is the actual path where I have this conversation CSV file and I loaded this CSV file now. Now let me convert it into the data set. Okay, so if we look at this data set, this is essentially a data set object which has certain features: context, response, index, input, and index level. It has 3725 rows. We can even load any of the indexes and look at the corresponding values. Now, once we have pre-processed the data, we are ready with our necessary libraries. I want to show you how you can actually utilize the Microsoft Dialog GPT for your conversations, right? So Microsoft Dialog GPT in its documentation has provided a certain technique, certain methodology using which you can carry on multi-turn conversations. So this is what I'm trying to build through this particular function that I have. We are taking a 5-turn conversation chain, and for each time, whenever if it is the first conversation, then I'm creating a new input. I'm considering an input from the user. I'm appending an EOS token to it, and thereby I'm encoding it using tokenizer. This appended input ID next will be concatenated with my history of IDs, and this history of IDs along with the new ID that I have generated will be passed to the model for generating the desired output or desired response. Okay, this is how things are going on. Let me show you with an example. So here, when I call this function, I have specified the first input as hi, I am Samantha. The dialog GPT responds as hi Samantha, hi are you? Or let me just run it for you. Okay, I'll run this function. I'll run this chain. So you see how this conversation chain is turning out. So it says, I'm glad to hear that. Thank you. Okay. So our 5-turn dialogue, 5-turn conversation chain is now completed. We passed the input for 5 times and the model generated the corresponding responses accordingly. Okay. So you can even utilize the input that we have and pass it to the model, check the results. I tried this here, but just this is a similar example. I'm trying to help you understand how you can actually utilize this Microsoft Dialog GPT in production. There is a certain technique which I have used in this particular function, wherein we are just utilizing the conversation history, appending the new input to this history, and then passing it to the model for generating the desired response. Okay, cool. Now, the next thing that we are going to generate is the training pipeline. So in order to generate the training pipeline, we already saw this training pipeline when we went ahead with fine tuning our GPT-2 based model. The training pipeline remains the same. The only thing that is going to differ is how we tokenize the inputs and how we pass these inputs. So let us see how we are going to tokenize these inputs. So for tokenization, I have created a function here. This function essentially takes the examples, the input feature of the examples. The input feature is what we generated by concatenating context and response. We have turned on the truncation. Padding is set to max length and max length has been specified as 40. Okay, And we because this is a supervised fine tuning, so what we are also trying to do is we are also generating the labels. Okay, so cool. With this we have generated our encoded inputs. Now we are going to split our entire data into train and test. This splitting is on the basis of 80-20 split. We utilize the functionalities with respect to the data sets library. We are using train test split. Then we are creating a split map on the encoding that we already generated. This is the function and the corresponding input that we provided here. Okay. If you just run this, it will make things clear. Okay, you see. So in our training, we have 2980 samples, and in our test, we have 745 samples. And our encoded data looks something like this. Okay, now so far, all good. Next, we import the training arguments and trainer module from the transformers library. These are necessary in order to actually fine tune our model. So we specify some of the arguments as the output directory, fine tune dialog GPT. Then we specify the training epochs, per device train batch size, per device eval batch size, weight decay, learning rate, FP16. Okay. This is actually the precision. If you want to go for a higher precision, depending on the resource that you have, you can even go for FP32. But here we are utilizing the 16-bit precision. We can check the device arguments, and the device arguments are essentially the CUDA. Okay. Now, once we have our argument set, our training arguments generated, just as we did in our earlier fine-tuning video, we are going to create a trainers object wherein we are going to specify the model, we are going to specify the training arguments, and we are going to specify the training and evaluation data set. Okay, fine. Yeah. So uh, now all things are set. Next is to only run this model. But before running it, what we can do is we can evaluate the results before and after training to compare how the results are going on. So essentially, we are running this trainer.evaluate on the test data set, and we are predicting the values corresponding to a smaller range, say a range of 10 values. Okay, to just to compare the results. That's it. Now that we have ran this evaluation, let us look at the loss. So evaluation loss before any fine tuning is 7.86. Okay. Rest of these are just the log information. We don't need to know about that. Okay. Now let us quickly head over to the fine tuning. Now I'm not going to run this fine tuning again because it takes a lot of time. I already ran this fine tuning on Google Colab. You can just go ahead and run this and it will work just the fine. Now after we train this, right, after we run this fine tuning process, let me show you the evaluation results. So post eval results after fine tuning is 1.02. We ran this for 10 epochs, remember. Now you can run it for more epochs and get further refined results, better results. You can even try to include some additional samples, customize on the data set that we have, and try to create your own logical fine-tuned model, right? So this is how your entire fine-tuning goes. You just take a data set, you import the necessary libraries, you pre-process the data set into a format that can be understood by the causal language modeling process because we are utilizing the GPT model. So the causal language modeling process goes as you have inputs. So for those inputs, you pass the first sentence and the model's objective is to predict the next sentence, which is the next sentence prediction objective. Now, in this manner, you create your data set. With this data set, you specify your training arguments. You already have your tokenizer, you have your model, and then finally you go for the training or fine tuning using the trainers module. Hope you learned something new. If you enjoyed the lecture, make sure to give it a thumbs up. If you're new to the channel, subscribe to never miss a video and stay on top of your AI journey. See you in the next video. Have a nice day. Bye bye. Jai Hind.